So in this video, I will be discussing code forces around 996 related for division 2. So I will be discussing first three problems of this set. Let's start with problem number A, that is two frogs. Okay, so let's start understand it here. So we are given some number of lily pads and you can assume they are some platforms. Okay, and we are given two frogs. For example, first frog is on this platform and another frog is on this platform. So they can either move to the right platform or they can either move to the left platform. Okay, either of these platforms, but there's some condition. If my current frog is on this platform, then he cannot move to the left, right, and similarly for the right also. But there's also one more condition. If another frog is on right of the current frog, then my current frog cannot go to the right. Okay, so these are the some conditions for the jumping. Now this, for example, this is Alice and this is Bob, the name of the frogs. Now tell me whether my allies can win or not. And when my current frog can win, the, there's only one condition when my current frog can win, and that condition is like that my another frog cannot make a move. Okay, so when can allies win? That we have to tell them, like, with the current configuration of A and B and the given n, I have to tell them whether my allies can win or not. So if we justify the question, for example, if Ella is on this and Bob is on this platform, and there is currently one more platform between them. Elias will move first and it will go he will go to the this particular platform. And yeah, don't tell me whether Bob can go to any another platform or not. The answer is no, because there is no right to it, and on the left there is Elias, so he cannot move. So the Elias wins. So do you notice one thing, that if like for example, if I take it from the scratch, if Elias on this platform and there are supposed uh, three platforms between them and the Bob is on this platform. Now whatever move they made, the difference between them, the difference between the number of platforms between them, that the parity will be same only. For example, if Elias moves on this platform, okay, done, and Bob's moves on this platform, okay, now uh, both have made their turn. Now the difference between the platforms is the same. The initially it was 3 and now it is 2, now it is 1. So these are both odd. That's what I'm trying to say. Like the parity will be same only. But how does the parity matters? The parity simply matters because in the first case we have seen, if the difference between them is odd, for example, this is Alice here and Bob is here, and yeah, what is the difference between Alice and Bob? That is 2, right? So if the difference between them, Alice and Bob, is a even number, then only Alice can win, right? So yeah, this is the only condition. Check whether the difference between Alice and Bob is odd or even. If it is even, then Alice will always win. If it is odd, then Bob is always win. So these are the simple conditions which you have to check. And just a reminder, like after each and every turn of Bob and Alice, the difference between them will be constant only. Yeah, that is the main funda. So yeah, hope so the problem statement and answer is clear to you. Let's now discuss problem B, that is B crafting. So in this question, we are given two materials. Let me take an example from this only. Okay, so yeah, here we are. Mm, So initially we have this much of material for each and every. Okay, for example, we have to make a cloth. Okay, uh, okay, let me take an example. We have to make a material and we have to make a thing which requires some number of materials. And suppose we need one unit of zeroth material, 4 unit of oneth material, 4 unit of twelfth material, and 0 unit of third material. Okay, done. But initially what we have this quantity of each and every material. But with what we can do, we can, for suppose I want to increase the unit of this ith material, then what I can do, I can borrow a unit of other materials to construct a material of ith type. For example, if I want to increase one unit of zeroth material, then I will increase it by 1. But in this case I have to decrease one from each and every other material also. So that is the condition to create material of the ith type. So I will decrease it 4, decrease it 4, decrease it 0. Okay, done. Now the answer is mean. Now the final answer will be whether I can make my material, whether I can make my thing or not, which require this much quantity of material. But originally I have this much quantity of materials for the each and every IS type. Hope so the problem statement is clear to you, but how to solve it? Answer is very simple, but I'll tell you how. For example, this is my, I'll take this only. Yes, so 1440. First of all, I will calculate what is the okay. Let's take a reference of the code only. Okay. First of all I'll take what is the maximum, what is the increment in the number of material which I required. Okay, what is the maximum increment in the unit of material which I required? Let me repeat it again. What is the maximum increment which I need to be required in my ith material? For example, in the zeroth case, you can see this is initially 0, and what I want 1. What is the increment required? The increment required is 1. Okay, done. Here is no increment required. Here is no increment required. Here is also no increment required. Okay, done. So the net increment which is required is 1 only. Now what I will try that this much increment is needed. Yes, this much increment is necessarily needed. So what I will check the decrement case. For example, in this case, I want to decrease it, right? I want to decrease it. So if the decrease quantity is same as the maximum increment, then it is true for that particular ith element. And if it's true for all of the elements, then my answer is also true. For example, in this case, the decrement required is 1. Okay, done. Here decrement required is also 1, and here decrement required is also 1. Yeah. So in all of these cases, the decrement is same as the increment. So answer is always true. But there's another more cases. Let me tell you what are the case. If you notice this case 1 10 3 3. Okay, so 1, here it is 1, here it is 1, here it is 3, and here it is 3. Okay, done. So how to proceed with it? Now what is the net increment required? So the here increment required is 2, and here is no increment required. So yeah, and what is the net decrement? Here is no decrement required, but here decrement is required of 7. But yeah, if you notice one thing, I only want surplus. Like for example, if I am having 3 units, then it is enough. But if I am having 3 or 7 units, then it is also enough, because the minimum quantity is required 3 and 3 only. The extra units I don't care. Question is not saying you cannot have extra units. So yeah, if my decrement is greater than my increment, then answer is also true. So yeah, but there is one more case. For example, if I am at 7 and my decrement required is 1, and let's suppose I am at here 1, and here increment is required of 2. Okay, done. Now in this case, if you see, the decrement required is 6. Okay, yes, and the increment required is 2. Decrement is 6, increment is only 1. So you have to decrease this much part from your answer. Yes or not? I have to decrease this much amount, because if I am borrowing something from my other parts. Okay, I think so. I have missed thing. This would be 1. This would be 2. Let's suppose this is 7. Yeah. So yeah, this is the increment required. I was calculating the increment. So yeah, original it is 1, and the increment required is 7. Okay, done. And let's suppose the decrement part would be, let's suppose it is 3, and I want it to be uh what I want. Let's suppose I want 1. Okay, done. Here increment required is 6. Yes. So if I'm increasing, uh yeah, so here I want increment. If the increment required is 6, then I will also decrease that particular increment from the other parts of the A. Yes, A, yes, from the A, yes. So if 6 is the increment, then 6 must be subtracted from this number also, right? If I subtract 6 from this number, then this is negative, which I cannot have. So yeah, some of the cases are this. For example, 6 minus 3 is clearly a negative number. Yeah. So here you can clearly see my material cannot be negative, but I want 1 over here. So that's the case. You cannot proceed with it. So these are some simple conditions. If I show you the cases here, I'll take the input and find the max increment first. If my b is greater than a of I, then I will calculate the maximum increment. Okay, done. And store it as a max increment. Okay, done. Now in another case, I will check what is the max decrement required. For example, if this is the increment, yeah, this then this increment will be subtracted from each and every number of a also, right? And by subtracting the number from a, if it is smaller than b of I, which is required to me, which is required to me, then answer is no and just return. And you can see this was the decrement in this case. This is the number which is required in my first case, but this must be subtracted from other parts of the a also. But you can notice, if I'm subtracting this from other parts of ai, then it is not equal to 1, or in fact it can be greater than 1, but it cannot be smaller than 1. But in our case it is smaller than 1. The answer is no. But if you notice in this case, here the increment was 2, but my 10 minus 2 was greater than 3. This is acceptable to me because I can have extra elements, but I cannot have negative elements. Okay, so these are the conditions which you can satisfy. I'll give you the code in the description. And yeah, let's now discuss the last problem, that was C, the trail. Okay, so I'll just construct the grid over here. You can skip the implementation of the grid. Okay, okay. So there's a grid given to us, and the condition which is given to us, that I'll just explain you the question. What is question is asking to you? Okay, yeah. So this is a grid given to you, and there is a path from zeroth index to the n comma n index, right? N comma m index. And for suppose, let's suppose the path which is in our case is this. Okay, done. And there's some other values. For example, these are the points which are filled with some numbers. Okay, done. Some numbers are there over these indexes. Okay, done. But what question is asking you to do to fill the and uh, these, and the path which is being created is now set with zero number. Okay, done. Zero integer, right? Suppose there's an initial grid, okay, with numbers and numbers, but someone came and created a path in the grid and set all of the numbers on the path to zero. Okay, done. And now your goal is to find the original grid, which contain all of the numbers in the place of path also. Okay, done. But there must be some other conditions to solve the question. Yeah, there is a condition. And what is the condition? The condition is simply the sum of each and every row is equal to sum of each and every column. For example, the sum of this particular row, and this row must be same as the sum of column, this column, this column, and this column, and this column. And that is only one number. Let's suppose it is x. Okay, done. So the sum of each and every row is equal to sum of each and every column, that is x. So how to solve this question? Let's suppose we are calculating the sum of each and every row. Okay, for example, the sum of each, you find a sum of each, you find a sum of one row. Okay, let's suppose it is s. Okay, done. You find a sum of each, you find a sum of one column. Let's suppose that is also s, because there's the same, right? And you know one thing, mm, that okay, let me take another example in under terms. The sum of one column is, the sum of one row is s. Okay, done. If I multiply this sum with n rows, then wouldn't it be the sum of my whole grid? Yes or no? The answer is yes. And similarly, you know one thing, this s is also sum of each and every column. If I multiply it with the number of columns, then this is also equal to sum of whole grid. And these are both equal. Yes. So what does it signify? What does it signifies? That my n by m is equal to s by s. Okay, done. And if I cut it out, then my s n equal to m. But this is not our case. It cannot be true in our case. It is not a perfect square grid. Then what are the other condition in which this equation can satisfy? Let's suppose r sum is 0. Let's suppose r sum is 0. Then what will happen? 0 into m equal to 0 into m. Then my 0 equal to 0. Then is my condition satisfying or not? Yes, my condition is absolutely satisfying. So what I'll take sum as 0. I'll take x as 0 only in each and every problem, in each and every test case which I have. Okay, hope so you get the conclusion. How I'm getting the sum as 0. Yeah. So I'll just make it next. Okay, done. Now my x is equal to 0. Now, now hope you got the point how my x is coming 0. Yeah. So I'll take x as 0, and what I will do next? Just run a greedily and find the answer. And what is greedily thing? Okay, I'll tell you that also. Okay, done. So let me copy paste the grid. Okay, is there any way to? Okay, yeah, this is better. Done. So this is my grid. Now you know one thing, uh that my sum of each and every column is 0, and the sum of each and every row is also 0. Yeah. So how to proceed with it? Now what is the sum of this particular string? That is, I'll calculate over here only. Uh, that is 25 plus 2 plus 9 plus 11. That is 47. So what? Now in this case you can see the only path was DTD error. This was the path given to me, and I have to fill this path. And you know the sum of this particular row is 47. So I will write 47 over here simply. Okay, I will write 47 over here minus 47, because you know one thing, that x is always 0. I have proved it in above step. Okay, minus 47. Now what is the sum of this particular 6, 13, 20, 22? 6 plus 13 plus 20 plus 22, that is 61. I guess I was wrote right, and yeah, that is 61. So what will come at this point? That is minus 61. What will come at this point? That is something which you can guess, and similarly fill the whole grid. Now you might be wondering that whether it is right or not. But yeah, we have proved in above said that x can be answer. X can be a sum. X can be a sum of whole grid, whole row and column. So yeah, just fill the grid gridly and you will find your answer. Yeah. If I find if I want a, you can see the answer of this case, this case, that is minus 47 minus 61, and the sum of these particular strings are 50. So minus 50 over here. Some of these particular strings are 44. So minus 44 over here, and the subtraction of all these negative numbers is 202. So I'll write positive 202 because this is covered by all the negative numbers. So you can see the grid over here. So this will be your final answer, taking the sum as 0 in your case. The implementation also easy. Just take the grid over here, and yeah, if your current string is saying SD, ideally this is not mattering in our case, but yeah, initially it is 0 comma 0, and find the sum of current row. Find the sum of current row. Okay, and assigning the answer as minus of sum for my I and j. And you know, if it is down step, then I will decrease my I. If it is right step, then I'll increase my j. Similarly, find the in other case also. I think this is a repetitive step, but yeah, just find the sum of each and every row and assign the negative of that to your current row, current value, and just increase d or r respectively. And similarly fill the last column and find the answer and print the answer. Hope so it is clear to you. Yeah. So this is the explanation of first three problems. If you have any doubts, please comment me down, and yeah, stay tuned for the next one. Thank you.